All right. So there's my triangle inequality theorem. We solved this out just using your algebra method. 6x plus 2 is greater than 2x plus 10. Subtracting 2x from each side and subtracting 2 from each side, I get 4x is greater than 8 divided by 4. X must be greater than 2. So that's one possible restriction on the value of x. Now I say, well, but what if that isn't the largest side? What if the 5x minus 9 is the largest side? Well, we set up again. Then 2x plus 10 plus x plus 11 has to be greater than 5x minus 9. So we just rearranged it. And here I get 3x plus 21 is greater than 5x minus 9. So subtract 3x from each side, add 9. I get 30 is greater than 2x. Divide by 2, I get 15 is greater than x. Or if I'm going to switch that so x comes first, x is less than 15. Because if I switch sides, I have the inequality still was pointing at the x, that's still be pointing at the x, right? So I now know that x has to be greater than 2 and it has to be less than 15. But what if that's not the longest side? What if this is the longest side, the x plus 11? Well, then 2x plus 10 plus 5x minus 9 has to be greater than x plus 11. So 7x plus 1 has to be greater than x plus 11. Subtract an x from each side, subtract 1 from each side, I get 6x is greater than 10. How did that come out differently for me before? I think I must have made a mistake when I did a calculation before. No, I did it with somebody with the homework, so 7x split it. Okay, yep. No, that's okay. I must have made a mistake. I did this with somebody in there, and I must have made a mistake in a calculation on this problem, because this is correct. So x is greater than 10/6, which is 5. X is greater than 5/3, or 1 2/3. We can put it as a mixed number just for comparison's sake. All right. So I know x has to be bigger than 2, x has to be bigger than 1 2/3, and x has to be less than 15. Only 2 of those are the most restrictive. One of them is a little bit outside. So if I were to put this on a number line real quick, just to kind of see what's going on, and that might be the best way to evaluate it. Okay, here's 0, here would be 20. X has to be less than 15. Okay, so it has to be going this way. But it has to be bigger than 2, and also bigger than 1 2/3. Okay, now the 1 2/3 would cover up that 2, so that's, we want the most restrictive range, not the least restrictive, the most restrictive range. So I have to be in there, and the 1 2/3 we don't wind up using. So I get that x must be between 2 and 15 in order for that to be a triangle. Now it's the most restrictive thing that's really the challenging part here. But it, how are we supposed to what? Yeah. 2. Well, I mean, you just figured one side. X has to be greater than 2. Or you probably did equals instead of an inequality, because a lot of people forget that these are inequalities, not equalities. Now, these aren't equations. These are inequalities. So that means the symbol is not an equal sign. It is a greater than or a less than sign. That's what we're working with in these last 2 sections. And honestly, that's one of the biggest problems people have on this next quiz, is they forget that we're working with inequalities instead of equations, and they just make everything equal to. And we aren't dealing with equations here. We're dealing with inequalities. Now, most of the technique for solving inequalities is exactly the same as for equations. We do exactly the same things. The only thing that's different is if I divide it by a negative number, then I'd have to switch the direction of the inequality. That's something you learned back in 7th grade or so. So if I have something like negative 2x is greater than 10, and I need to solve that by dividing by negative 2, I have to switch the direction of the inequality. Or I divide by a negative. I can add or subtract anything I want. It's only if I divide by a negative. Dividing by a positive is not a problem. Multiplying by a positive is not a problem. Only if you multiply or divide by a negative do you have to switch the direction of the inequality. So that's how we set something like that up. And that would be definitely an extension style problem on a quiz. That would not be a regular problem. So now you've seen 33, you could probably do 34. Any questions on that? So I tell you what, now that we've seen 33, let's do a very quick open book, open note quiz on number 34. You may use your own book. You may use your own notes. You may not use anybody else's stuff. So just get out a piece of paper and do number 34, which is very similar. If you don't have a book with you, I guess you get a 0 on this because you're not bringing your book to class. That's a shame. But same page we were working on, page 332. No, you may not borrow a book off the shelf. No, you may not go to your locker and get your book. Or if you have it in your notes because you already did it in your homework, you may just copy down what you had in your homework. That's fine too. Yes. You can copy down anything that was in your homework, or you may use your book. Help set up and solve the problem. But if you're not bringing your materials with you, I guess you can't do the quiz, which is kind of the point I'm trying to make here, is that you need to have your materials with you in order to be successful.
Do we have to rip this paper out?
You will have to turn this in, yes. Just a couple points, just a couple quick quiz points, but now I've done number 33. I'll even leave that up on the board as an example. Okay? 34. Okay? I'll give you just a few minutes, and like I said, I'm sorry if you don't have your materials with you to be successful. Hopefully next time you will. And no, you may not share somebody else.
We should be able to look at
No. If you don't, no.
I'm going to draw you a picture anyways.
You don't have the materials, you don't have the materials, you're out of luck. It's not this is not going to be, it's been like just a couple points. Okay? It's not a big deal. It's making the point.
Let me try.
If you don't know what the problem is, it's going to be kind of hard to do.
No, I have a problem, but what if I just do my best effort?
And I just completely screw it up.
Just do what you do the best you can. Do the best you can. Or if you've written down the problem completely in your homework and you have it that way and you didn't have your book with you, but you have your homework, it's really well done, you don't need the book. about another minute, even if you're not completely done, we'll just take where you're at. All right, let's have you just kind of tear them out, pass them forward. What you got? Never exciting. Yeah, I just decided that, instead of
What about those
Driving
that
at
actually
people.
be really good at that?
that this is just a way of reminding people that these are going to come from the book sometimes, it might come from the notes from the day before, stuff like that. Just kind of encourage you to be doing the things you should be doing.
So we're not on this.
It's okay, we'll take what you get. Where'd you get that information from? Just happen to have it written down?
Yeah, I just got it.
How many points is it?
Just a
Do
couple.
you know where I from?
Just a couple.
So it won't really hurt.
Yeah.
Oh, it's not gonna like kill your grade or nothing, no. It's not like we're 300 points or something. It's like we're maybe like 2 quiz points or something like that. No, normal quiz is worth 100 points.
Okay.
So it's like very, very, very minimal. But it's just something to keep you all accountable for having the right things here at the right time. Taking notes, doing stuff like that. So we can do it.
Can I just leave my book here?
No, I'm not the storehouse for books.
You leave me out of the summer.
Yes, over the summer you may leave it here. Because that's when it's my responsibility for the books over the summer. Once they're checked out to you, they are yours. There is an online edition, yes.
I know there is
is.
online. When my back hurts.
When you switch to,
What do you say about that?
semester, should I
No, you keep your book.
just send it in?
Yeah, like what if
Yeah.
I already have back problems because of excessive food on my locker is like 5 miles away?
Well, there's always surgical options.
Some people don't have all the money in the world.
If it's medically necessary, usually insurance will cover it.
What if we don't have insurance? I'll sue you.
That's why the schools have provided you with a locker to store things. You can visit between classes.
Yeah, I'll be late to this class every day. Is that okay?
You know what? Find a way to make it work. Find a way to make it work. All right. Because we're all nice, getting to be nice grown-up people now. Hinge theorem. The hinge theorem is what we're going to talk about today. And again, this is not going to be something that's extremely difficult. This is not very hard. We kind of talked about it yesterday with the fly swatter example. If I open the angle wider, the third side gets wider. If the angle is smaller, the third side gets smaller. If the two sides are the same that we're talking about. Okay, the red and the black sides are the same. They're congruent. They're designed to be that way. And as I open the angle up wider for angle 1 versus angle 2, which has a longer third side?
What?
Obviously. Okay? That's what hinge theorem says, because it's like a hinge. It's considering the angle to be like a hinge. And essentially what we have is what's called a type of a side angle side situation. It's just that the angles aren't congruent now, the angles are different. So if I have a pair of congruent sides, and again they've indicated that by color here, we can also indicate it this way. If I have a pair of congruent sides, but the included angles are different, The one with a larger included angle has a larger third side. The one with a smaller included angle has a smaller third side. Makes sense, right? I mean, it's totally logical. It's not and intuitive, almost. So you're going to see this in problems. The converse is also true. If there's a longer third side, there's a larger angle. If it's a shorter third side, it's a smaller angle. Here I have a parallelogram. I admit it's a little bit small. I can expand it a little bit, but it's all together. I have what looks like a parallelogram, but it's not quite because the opposite sides are not congruent. In fact, in this shape, this is 24 inches PT and RS is 23 inches. However, I do know that these sides are congruent because they're indicated, and I have a shared side that's congruent. The question is, which angle has to be larger? Well, we're going to compare the angles opposite the non-congruent sides. So we're going to compare angle PST and angle angle SPR. Because these are the unequal sides, so they're indicating what we're going to compare are the opposite angles. Which one has to be larger? PST has to be larger, yes. There we go. Honestly, the hardest part about that is figuring out what it is you're comparing. Once you figure out what you're comparing, figuring out which one is larger is actually quite simple. In this situation, let me expand this as much as I can too, make it a little bit bigger for us to see. It says PR equals PS, that's indicated in the picture. Measure of angle QPR is greater than measure of QPS. So measure of angle QPR, this is the bigger angle than this one. Okay, so this one's larger, this one's smaller. If these are the two angles that are unequal we're comparing, then we're going to have to look at what are the opposite sides. Because those are the sides we'll be comparing. Because we're comparing those two angles right here. So the two sides we're going to have to compare are RQ and SP. No, it actually, RQ and SQ, excuse me. And it tells us that. SQ and RQ. Which has to be greater? If this angle is larger, RQ must be the longer side. That's all there is to it. Hinge theorem. Pardon? No, actually, because we're comparing the lengths of the segments, I don't need the segment symbols. Because the lengths are numbers. If you put them on anyway, I wouldn't mark it wrong. But technically here, we're comparing the lengths, so the symbols aren't necessary. Don't you hate when he's got an answer for that? It's annoying. This is kind of a fun problem. Two groups of bikers leave the same camp heading in opposite directions. Each goes 2 miles, then changes direction and goes 1.2 miles. Group A starts due east and turns 45 degrees towards the north as shown. Group B starts due west and turns 30 degrees towards the south. Which group is further from the camp? Explain your reasoning. All right. So, what we want to do with a situation like this is what first? Maybe draw a picture, right? A little bit of a picture, but not the whole thing. So let's let this be camp right here in the center. That's camp. That's the fire pit. See, that dot represents the fire pit. Because everyone left, and they put out the fire.
I mean, like, draw a tent so we know what's the case.
No, that's the camp. That's all that's left is a fire pit. All right, because they left. They broke camp. They took their tents with them. They packed out their trash. The only thing that you have is left is maybe a fire pit. That's it. They're responsible campers. Responsible campers. All right.
Explain your reasoning. Good job.
All right. First group goes 2 miles due east, then turns 45 degrees towards the north. So it goes 2 miles this direction, and then they turn 45 degrees towards the north. So this is a 45-degree angle right here. towards the north, and they go how far? 1.2 miles that direction. Okay. The other group goes 2 miles due west and turns 30 degrees towards the south. Okay? So that's 30 degrees. Now the question, and also goes 1.2 miles that way. The question is, which group is actually farther from the original campsite? Group 1, this is group 1, this is group 2. So the question is, which of these green lines is longer?
Top one.
Okay? But the way we figure that out is by figuring out which one of these angles is greater. But it's not the 45 and the 30 we're comparing, is it? We're comparing this angle, which would have to be supplementary to 45, which is 135, and this angle, which is supplementary to 30, which is 150. Group 1 or Group 2 is farther from camp? Group 2. Okay? But the picture is essential. You can't really solve that without the picture. And you have a few problems like that, but it's an application of the triangle inequality. Now, if you get into trig and stuff like that, then we can actually start solving how far is each one from the camp. We can actually find the distances. We need trig for that, but it's the kind of problem we can work with. Great. I teach it in pre-calculus. We actually will do some trig in geometry. We do basic trig in geometry. Second semester. So.
What's the math after those?
Algebra 2, yes.
Then pre-calc and then...
Then pre-calc or algebra 3 or... and for
Better.
You do pre-calc.
well, I mean, pre-calc is harder than algebra 3. Algebra 3 is more of a review class. And after actually this, some people, depending on test scores, you can go to algebra 2, you can go to intermediate algebra, you can go to honors algebra 2. There's actually 3 classes you can go to.
What's intermediate?
Intermediate is kind of like some people call it algebra 1.5. So it's a class that you take for a year, and then if you do well in that, then you go on to algebra 2 after that.
And what's after algebra?
It depends on your grades, actually, in algebra 2. B's are better, you can go into pre-calculus. Lower than B's, you go to algebra 3 and stats. Or trig, or a bunch of different options. There are a lot of options. So we'll talk about that more in February or January as we're getting close to. Okay, let's set up an equality and solve for x. All right, clearly I've got 2 congruent sides are indicated. I have a shared side right here. So I've kind of got my side angle side. This angle is 63 and this angle is 49. So we're going to compare these angles, which means we're going to compare these sides. Right? Which angle is larger, the 63 or the 49? This is not a trick question. 63 is obviously larger, so which side has to be larger, the 3x minus 1 or the x plus 7? 3x minus 1 must be larger, so we set up our inequality is greater than x plus 7. And we simply solve that. I get 2x is greater than 8, so x is greater than 4. You know what? The biggest mistake people make on this problem is, like I talked about before, they put an equal sign there instead of an inequality symbol.
If we did that, but then our answer was an equality.
You'd want to have it all set up as an equality, set up and solution. I want to be a little bit careful too. I don't want to do minus 3x to both sides, give myself a negative 2x because I divide by negative 2 and remember to flip the inequality. It's not that you can't do that, it's just that you're much more likely to make a mistake. I'm going to stop with the pencil thing. Thank you. All right, so that's kind of what's going on with this whole inequality thing. Now, there is another part to this section that we do not cover. You'll see some comments about indirect proof. We do not go over indirect proof as part of geometry. That's something that you'll have to pick up in higher level math if you get to those points. Probably not till more of a college level math will we really worry about indirect proof. It's a totally different way of thinking. Actually, it's very useful because a lot of things can only be proved indirectly. The principle behind indirect proof is basically this. I'll give you the overview of it. If I want to prove that something is true, I start by assuming that it's not true. And then I show that that is impossible. So if it's impossible for it to be not true, therefore it must be true. That's the idea behind indirect proof.
Why would you do it that way?
Because some things can only be proven indirectly. So from a logic standpoint, it's necessary. But for our purposes in here, it's not going to be necessary. So we are going to do indirect proof. One thing I am going to do very quickly, though, is just do a quick review of special segments and triangles, because that is going to come up again when we start dealing with the chapter test, which is coming next week, and then next Friday, I think, is the chapter test. So this is just a quick review of things we've learned before, and parts, special segments in a triangle. Notice I've got a chart here set up. The median. Does the median go through a vertex of the triangle? Yes or no? Yes, it does. Is the median always perpendicular to a side? No. Does it go through the midpoint of a side? Okay? And what do you call the point of concurrency for the medians? Not an android, but a centroid. Okay? The altitude. We didn't spend a lot of time with the altitude. We know I give you the point of concurrency because it doesn't do much. But does an altitude always go through a vertex?
Yes.
Yes, it does. Is an altitude always perpendicular to a side or an extension of a side?
Yes.
Does an altitude always go through the midpoint? No. Okay? Now this one, I gave it a little different. This one is perpendicular to a side and passes through a midpoint. Which one goes to the midpoint and is perpendicular to a side? I've got two left. The two left, just to give you a hint, are angle bisector and perpendicular bisector. Okay?
Perpendicular bisector.
Obviously, if it's perpendicular to a side, is it going to be angle bisector? Let's think about this before we open our mouths. Perpendicular bisector. Means this one must be angle bisector. And is an angle bisector always go through a vertex?
No.
Yes.
Since a vertex is how we create the angles, maybe an angle bisector should go through that. Just saying. Does it have to be perpendicular to a side? Does it have to go through a midpoint? No. Okay? So that's just kind of a chart that summarizes the properties of those special segments that we learned in the first two parts of this unit. And we're going to see it again. This is not part of your homework tonight. This is not going to be on your next benchmark, but it will possibly be on your unit test.
Do we have homework?
Yes.
Oh, yay. I actually did it last week.
And it's actually not that huge of an assignment.
I did it already. It's already done that.
3 through 10 and 16 through 18, so that's 8, 9, 10, 11 problems. It's not massive. There's no vocab. We'll have a review worksheet on Monday, and next benchmark Tuesday, then a couple review days. Next week there's no new material. It's all just review into the unit test. I'm not anticipating we'll get enough snow for a snow day on Monday, so I think
I think I had the wrong page.
That's going to be an ice day.
depending on who you talk to, I've seen everything from 1 to 2 inches to 2 to 5 to 3 to 6. I'm thinking it's probably going to be in the 2 to 4 range, which is of light, fluffy stuff.
I'm thinking, no school. Even if we had school, no school.